I turned these cheap Christmas lights into app-controllable smart lights. I want all my Christmas lights controlled through my smart home system. Christmas tree, check. Christmas stars, check. Ceiling decoration, check. These battery-powered Christmas light chains, not even close. I still wanted to keep them battery-powered so I could place them anywhere without running long and ugly power wires. So I built my own battery-powered, smart home-enabled controller from scratch. It might seem simple, you tap a button in an app and the light turns on. But to make battery-powered lights behave like that, there is actually a lot more going on behind the scenes. So let me show you exactly how I got it working. To control the lights, we need a microcontroller like this. It has Wi-Fi support, which enables it to communicate with Home Assistant. But there's a problem. If the microcontroller stayed connected to Wi-Fi all the time, it would drain the batteries far too quickly. And if we put it in a deep sleep to save power, it can't talk directly to Home Assistant because that requires an active Wi-Fi connection. The fix is to add a second microcontroller that has wired power and always stays connected to Wi-Fi. And let the boards communicate through ESP-NOW. The always-on controller receives commands from Home Assistant and then relays them wirelessly to the battery-powered microcontroller. To prototype the concept, I started simple. A breadboard, 2 ESP32s, a handful of wires, and a MOSFET to switch the lights on and off. The ESP can't power the light directly. They draw way more current than it can provide. So the MOSFET, basically an electronic switch, handles that part. Before connecting anything to the lights, I added a small configuration block to Home Assistant to create the on and off button. I kept the first test pretty simple. When I tapped the button, the ESP32 printed on or off in the serial console and toggled the onboard LED. Once that worked, I hooked up the MOSFET, the battery pack, and a light chain. Setting I/O pin 1 high powered the LEDs, and I was able to confirm that everything behaved as expected. Next, I wired up the second ESP32, the one that stays powered over USB. This controller listens on Wi-Fi continuously and receives commands from Home Assistant through MQTT, which is a lightweight IoT messaging protocol. When a command comes in, it broadcasts it for about 3 seconds using ESP-NOW, a super lightweight wireless system built right into the microcontroller. It doesn't use normal Wi-Fi, it just sends tiny packets directly between the devices, which makes it perfect for low power setups. The battery-powered ESP32, on the other hand, spends almost all of its time in deep sleep. It wakes up every 2 seconds, listens briefly for ESP-NOW messages, and then goes right back to sleep. If it hears a turn on or turn off command during that brief window, it toggles its MOSFET pin and the lights switch instantly, while still keeping battery usage extremely low. Once everything worked reliably, I soldered the components together and made the whole setup as compact as possible. Then I designed and 3D printed an enclosure that holds both the battery pack and the controller. To hide this ugly plastic box, I went a little bit overboard and designed a cover that looks like a gingerbread house. To avoid a million filament swaps during printing, I split everything into smaller parts that could be printed separately, and I could then glue them together afterwards. Once the pieces were off the printer, it was time to assemble everything. I started by gluing on a couple of sidewalls first and lined them up carefully. The superglue worked well, and I did my best not to attach my fingers to the parts in the process. Then I added some small extension buildings on the sides. I glued on some of the smaller roof panels. Next came the ridge boards. After that, the large roof panels. With the last pieces going on and my fingers forever preserved in glue, the assembly was complete. To keep it neat without leaving big marks on the wall, the enclosure is fastened with just a single screw. You might be wondering why I kept the original battery box instead of powering everything from the same pack as the ESP32. The simple reason is that I didn't have a voltage converter that could safely handle both the LED chain and the controller at the same time. It works fine as it is, but combining everything into one power source would definitely tidy things up. Maybe something for next year's version. So that's my battery-powered, smart home-enabled Christmas light chain completed. A mix of low-power tricks, wireless relaying, and a pair of microcontrollers working together behind the scenes. Now it is fully smart home capable, and I can automatically turn them off at night and back on again in the morning. Please let me know in the comments if you have any ideas for fun projects I can make in future videos. If you enjoyed this one, give the video a thumbs up and subscribe so you won't miss the next one. Thanks for watching, and I hope to see you again soon.